Welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. If you're new to the channel, please subscribe and click the notification bell icon for future updates. Today we are going to talk about questions relevant for AWS Associate level certifications.
Let's look at our first question of the day. Before we jump in, I would request you to pause the video, read the question, take some time to think about the question, and then write some answer that you think, choose one of the option that you think is the correct answer in the comment section. Meanwhile, let's start with the question. An e-commerce application is hosted in AWS. The last time a new product was launched, the application experienced a performance issue due to an enormous spike in traffic. Management decided that capacity must be doubled this time, this week after the product is launched. What is the most efficient way for management to ensure that the capacity requirements are met? So looking at this question, and maybe if you have paused the video and have some idea about what will be the good answer or the best answer out of these options, please don't forget to comment it out. Let's go from, maybe we can start from the option D from bottom. Add a step scaling policy. Now, if you have used step scaling, you would know that step scaling used to increase or decrease the current capacity of your auto scaling group based on set scaling adjustments that you have, known as step adjustments. Now, these are very useful in case the load is unpredictable and the adjustment vary based on the size of the alarm breach, basically type of the breach that happens or the alarm that has triggered. You can have a step scaling adjustment. So this is not something that we think is the best possible answer in this scenario. As of now, let's rule it out. The next option over here is add EC2 spot instances. Now, EC2 spot instances may or may not be available when you are looking for. The spot instances will definitely reduce the cost, but that is not what we are looking for. We are looking for most efficient way to launch the new product without having any kind of issue in the new launch based on the previous experience. So cost is not a factor over here. Secondly, spot instances can be lost, so you may have reduced capacity without any kind of notification. So this is not something that we are looking at. Spot instances are an issue over here. Let's look at the third option here, which is add a simple scaling policy. Now, even AWS recommends having a step scaling policy. The reason behind that is, like, simple scaling policy versus step scaling policy, the basic difference is the way it scales. Now, in the simple scaling policy, the scaling activity will not allow you to have another scaling to trigger until the scaling activity has finished. The previous scaling activity has finished. The health check is complete. There will be a cooldown period before an additional alarm can be taken or handled. But in this case, there is a cooldown period before another scaling can happen. So it is again for the unpredictable load, but not the most suitable option here. So as of now, I'll trigger a cross. We'll say a cross in front of simple scaling. Let's look at the last option here, scheduled scaling. Now, what scheduled scaling allows you, scaling based on a schedule allows you to set your own scaling schedule for predictable load changes. In this case, we know that there was a spike when the application was launched on a previous occasion, and the management wants you to double the capacity in the most efficient way so that it can handle that spike. And we know when we are going to launch the product, So it's basically scheduling that scale, and based on that schedule, you'll have a higher scale, and then you can go back to your production scale, the normal production scale, just adding additional capacity to handle that load. So this is the most ideal option in this particular scenario. Moving on to the next question. A company's application is running on Amazon EC2 instances in a single region, so just one region. In the event of a disaster, a solutions architect needs to ensure that the resources can be deployed to a second region. So we need to deploy this EC2 instance in a second region in case of a DR scenario. Which combination of actions should be taken, basically, should the solutions architect take to accomplish this? And we have to select two options over here. Please pause the video, take some time to think about the question, write the answer in the comment section. Okay, let's look at the options. Launch a new EC2 instance in the second region and copy a volume from S3 to the new instance. Launch a new EC2 instance in the second region. Basically, this option is incorrect because you cannot create an EBS volume directly from Amazon S3. Understand that this option is just kind of a distractor. You cannot do that. So you can discard this option. Copy an AMI, which is Amazon Machine Image, of an EC2 instance and specify the second region for the destination. Now, copy an AMI of an EC2 and specify a second region as a destination. So you can do that. This looks like a feasible option, so let's keep it as one of the options. Number C now. Copy an Amazon Elastic Block Store or EBS volume from S3 and launch the EC2 instance in the second region using the EBS volume. This is again the same thing. You cannot create an EBS volume directly using an Amazon S3. So it's a plain incorrect option. Let's look at the fourth option over here. Detach a volume on an EC2 instance, copy it to Amazon S3 bucket in the second region. Now this is the same region that this option is again wrong. You cannot copy an EBS volume to an S3 bucket and then restore it to the second region. The last option over here is launch a new EC2 instance using the AMI in the second region. So this one is step one, where you copy the AMI of an EC2 instance to a destination in the second region, and then using that AMI you launch the new instance. So option B and option E as a combination create answer for this particular question. Okay, this question, an insurance company has a web application that serves users in UK and Australia. The application includes a database tier using Mysql database hosted in EU West 2 and web tier in US 2 and Asia Pacific East 2. Amazon Route 53 Geoproximity Routing is used to direct user to their closest web tier. It has been noted that Australian users receive slow response times to queries. What changes should be made to the database tier to improve the performance? So if you look at this option over here, the question is telling you there is a DB. So you have a database in EU West to EU. And then you have web in basically EU West and Asia Pacific, Southeast too. So somewhere in Singapore. And then this is Europe, basically UK or someplace. Now, using the geoproximity routing, now geoproximity is that you have a route 53 and based on the request that is coming, if you are in Europe, you will be routed to the EU West, and then if you are somewhere near Australia, New Zealand, or Malaysia, it will go to Asia Pacific. But the database is sitting in EU West 2 only. So let's look at the options. In the meantime, if you want to pause the video, take some time to think about the question, and maybe write your answers in the comment section. The issue here is latency with read queries being directed from Australia to UK, because the database is sitting in UK while the website is basically hosted on both EU West and Asia Pacific. The solution required here is the read performance in Australia. The queries are taking time to load. So let's look at the options that we have. First option is basically deploy MySQL instances in each region. Deploy an application load balancer in front of MySQL to reduce the load on primary instance. You can only put an ALB in front of web tier, not the DB tier. So you can do that in front of your web application while this option doesn't fit well with this particular scenario. Now the next option over here is migrate the database to Dynamodb. Use Dynamodb global tables to enable replication in additional regions. Now this is a MySQL database. It's a relational database. Dynamodb is basically NoSQL. So using Dynamodb global table and enabling replication will work for any kind of load that is NoSQL. So if you have Dynamodb global tables, what will happen is if you have multiple regions, Dynamodb global table will allow you to write to the both regions, and it will automatically sync up using the Dynamodb stream. But in this case, the database is MySQL and not a NoSQL database. And that's why this is not an option here. The next option given here, option C, let's look at it. Migrate the database to Amazon RDS for MySQL. Configure multi-AZ in the Australian region. So now this one is basically saying migrate the database to Amazon RDS for NoSQL and configuring multi-AZ. The database is located in EU West 2, which is UK. If the database is migrated to Australia, then there will be similar issues on the UK side. Multi-AZ does not assist in improving the query performance. The next option, so this is wrong. Migrate the database to Amazon Aurora global database in MySQL compatibility mode and configure read replica in AP Southeast 2. Now, if you look at this option, configuring read replica in Southeast 2, we need to reduce the latency. Amazon Aurora database, which consists of one primary AWS region where data is mastered, and you can have like 5 read-only. Aurora replicates data to the secondary regions with typical latency, which is under a second. So you issue write operations directly to the primary DB instance in the primary AWS region. This will solve your problem that is happening in this particular question, and it will be the answer for this question. Looking at the next question, we have an Amazon RDS read replica is being deployed in a separate region. Master database is not encrypted. So the master database is not encrypted, but all data in the new region must be encrypted. The requirement is the data must be encrypted, basically. How can this be achieved? You can pause the video, take some time to think about the question. The requirement here is that the master database is not encrypted, while the data in the new regions that we are going to add should be encrypted. And how you can do that? So what kind of read replica can be encrypted? That is what you have to think about. So think about the question, write, choose one of the answers from the given options, and comment it out. Let's go through the options. Enable encryption using KMS when creating a cross-region read replica. Enabling encryption using KMS is incorrect. One thing to note is that you cannot create an encrypted read replica from an unencrypted. In this case, enabling encryption using KMS when creating a cross-region read replica is not something you can do from a non-encrypted master database. Next option over here is encrypt snapshot from the master DB. Create a new encrypted DB instance and then create an encrypted cross-region read replica. This makes sense because you're creating a snapshot and then you are creating a new database which is encrypted. The master database is encrypted, and then you're creating encrypted cross-region read replica. So we can keep it as one of the options that can be one of the best options that we have till now. Let's look at the other options. Let's look at option C, enable encryption on the master DB instance, then create encrypted cross-region read replica. So enabling encryption will not work because you can create a new instance, but you cannot enable encryption after the launch of the master DB instance. So this option is not correct. Encrypt a snapshot from the master DB instance. Create an encrypted cross-region read replica from the snapshot. So looking at this option, basically, you're taking a snapshot, encrypting a snapshot from master DB and trying to create an encrypted read replica, which will not work because you cannot have a read replica of a master DB encrypted if the master DB is not encrypted itself. So again, this option is incorrect. Finally, we determined that no other option is best suited in this scenario. The best option in this scenario is to encrypt a snapshot when the master DB, take a snapshot, create a new master DB which is encrypted using the encrypted snapshot, and then create an encrypted cross-region read replica.
This is the end of the show. Thank you for watching. If you liked the content, please like, subscribe, and press the bell icon for future updates. This is your host Bhavesh Kumar signing off. Thank you.